So in this video, I want to tell you about two new attacks: HTTP response splitting and request smuggling. Let's start with response split. Here we exploit the fact that the user provided data is included in the header of a reply. And what do we want to do with that? We want to poison an HTTP, so a web cache, a web proxy. Okay? So it's web cache poisoning attack. It's a web cache poisoning attack. Let's have a look at an example. And the idea here is that we have a website and it does some redirection based on the language. Okay, so here's you see some code that is part of the application, and it sends a redirect by language. So the language equals whatever the language might be that is provided in the header of the request. Okay, so you're sending it with your language equals English, and then it will go to the appropriate redirection site. Okay, for instance, here it will say it's moved temporarily, blah, 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 location equals this one, right? By language. So the language equals English. So that's nice. Then now your browser knows where to go for that for the content that's moved temporarily. But note that it uses some information that was provided by an untrusted source. The language, right? So English in this particular case is part of the header of the GET request. So, and that means that we now have some way to influence this value that is provided here. And what can we do with that? Well, what if we call, if we access this, if we go to this website, what if we call this with, the language equals something or other, foobar in this particular case, and then, this weird looking string. Well, it's weird, but you can still, recognize something that looks very much like a header, an HTTP header, right? So an HTTP 1.1 we see here, and it has something like, so %20 is space, so 200 is probably the success or failure code. 200 is okay, and it has some content type, it has some other stuff. That is weird. So this looks like a really weird language to be redirecting to. Okay, so what does this translate to? If the server includes the value of the lang variable that we saw earlier, verbatim, then the resulting answer looks like it might be two different replies. Like we can see, this is a reply, an HTTP 1.1 200 OK reply for a website that, I can't read all of that, but it's Shazam, right? So what is going on here? So we now have two replies to our one request. Now, if the attacker also sends a request for index.html, the second fake reply, so the reply that we see here that arrives at the web cache, will look like a reply to that request. So in other words, we've now poisoned the intermediate request. It will think that if anybody asks for the index.html, this is the appropriate reply. Now that's nifty. Okay. Just to make this clearer, what we're going to see is that the response contains a moved temporarily, as we saw earlier, with the language equals foobar, so it's a new location, and we want to appropriately redirect it to something that is appropriate to your language. So in this case, foobar, and the content length is 0. And then there's a second reply. Okay, it's a second reply, and it contains some actual content. Now, if we send a second request for index.html, the intermediate web cache will think that this is the request this is the reply for index.html. So we've poisoned the intermediate cache, the web cache. A related but somewhat similar vulnerability or problem is known as HTTP request smuggling. So now we're talking about the requests, and here the attacker sends a weird message to the web cache, and the web cache will then have to do a request to the actual server. And what we're going to make use of is the fact that maybe the web cache, the proxy, processes these requests slightly differently from the actual end server, the content server. Okay. And the request is weird, right? It's a post request to some host, blah blah blah, and then we have these two content lengths. We have two content lengths. That's weird. And then we get all of this stuff, and it contains gets and gets. That's really odd. Okay, so let's say that the web cache gets this request first, and it decides to ignore this first header, right? So it just takes the content length to be 44 bytes. So it's a post request going to some website, a post request of 44 bytes. So we have a carriage return line feed here. Then we have a bunch of bytes here. All of this will be taken as the content in the body of the first request, 44 bytes. So that means that we're basically getting rid of this get, poison HTML, HTTP 1.1, host site, and blah. So that's the 44 bytes. We don't see that because it's just the content of the first post message. And then what the intermediate web cache will see is another GET request. So here's another GET request, and it's apparently, as far as the web cache can see, it's for the same website, and it's a page to poison.html. Okay, so that's the request that we're seeing. Great. And as far as the web cache is concerned, whenever replies come in, right, the first reply will be for this one, and the second reply will be for that page, for the page to poison.html. But if the server, content server, now has a slightly different way of parsing this request and takes the first content length to be the most meaningful one and ignore the second one. Right, so now it will basically say, okay, so the first one had content length 0, and then there was another weird, spurious HTTP header, which I'm going to ignore. There's a carriage return line feed, and then we see a new request here, right? So there's a get poison.html. Okay, and that's going from this site, and it basically has this strange value blah here, but that's fine because blah has a colon at the end, and it looks just like a custom HTTP header, which the server cannot handle, and the web cache doesn't care about. So this will simply be ignored as a spurious and not very meaningful header. You can add it as arbitrary headers if you want. Okay. So this will be ignored, and then it will basically see maybe another get page support request for a page to poison, and that's it, right? But the key thing here is that this one sees a new request for poison.html, a host site, and then a blah header. Now, the blah header has a space behind it, but it doesn't have a carriage return line feed. What does that mean? Well, blah by itself isn't interpreted as an empty header. It's interpreted as a header that contains the value get HTTP blah blah blah, and etc. etc. So this, in other words, is the value of the blah header. So that means that this gets ignored also. Okay, so in other words, we're seeing the server, the content server, will see a request for poison.html, and it looks like a completely legitimate request. So it will return the content for poison.html, which will be interpreted by the web cache as being the response to the page to poison.html. In other words, we've created desynchronization between the web cache and the actual end server. And because of that, we were able to provide the content for one page in reply to what the web cache thought was a query, a request for another page. So we've poisoned this entry there. So now this, I think, is all explained in the subsequent slides. I think I explained everything there was to explain about this already. You can read this in your own time. Okay, so the proxy and the server have a different way of parsing the request, and if you carefully construct your requests, you can make use of that. Okay, and the server sends back the content for foobar.html and poison.html, but the proxy server will associate that with requests, so a post request for foobar.html and page to poison.html. And so from now on, every client that asks for page to poison.html will receive the content for poison.html instead.